Today, I would like to speak about the role of quality assurance in the effective decontamination strategy. So, what is contamination? Contaminants comes from microbes, viruses. So, as Dr. Rangareddy mentioned that in our pharmaceutical industry, the sources of contamination is from personal, equipment, facilities, and environment. So, my presentation focuses on relevant regulatory guidances post COVID-19. So these are the contents: business continuity and regulatory landscape, QA role, and quality risk management. And I have taken 2 case studies and conclusion. Gives that our product is suitable for use, is fit for the purpose. A program is sum of all the activities which is being performed by entire industry. That's called our quality assurance. Business continuity. We have a procedures in place, but post COVID-19, we really implemented business continuity. We'll see what is business continuity here. And as I mentioned, US FDA has recently published US FDA, United States Food Drug Administration, post COVID-19, what are the preventive controls we have to take? How do we address the emergency situations? So once this pandemic situation, the facilities have slowed down, and the focus is on protecting our products. How do we protect our products? So most of our vaccines, pharmaceutical products, sometimes as a human beings, as operators, we may get impacted, and most of the times the product will get contaminated by us. So that is the reason we wear masks, complete protection of our human body, because we shed a lot of particles each and every time. So we have a clean room preventions. While we entering into a clean room, we have to remove our street clothes, and we have to have, from top to bottom, we will have a sterilized equipment, gowning procedures will make. And good practices, and there is a formal risk assessment to be done by all our industries. We will see what is the risk assessment, and there is a formal risk assessment in place. And MHRA is for UK, it's a UK regulatory agency, medicines and healthcare regulatory body. This also focuses on risk assessment. Both US FDA and MHRA focus on risk assessment part. So when we try to, while a person entering into manufacturing plant, we have several controls in place, like temperature recordings and sanitization. That's all being followed. When we have a suspicious manufacturing person, then we will isolate him based on testing. After isolation, what we do, before we take him into the roles, we have to have a medical certification in place. So apart from that, in the risk assessment, what we do, he might have contacted many places, many areas within the systems. So we see, we review the video recordings, the movement of the person, and we isolate the areas which we isolate the primary contact points, and we identify the secondary point of contacts, and we isolate them for a few days, and we monitor their behavior. Then only we will ask them to come into our premises. So once they come into role, they inform the employer about their fitness certificate, then we will take him into roles. Now we'll go to the actual components. So we deal with the primary packaging material, secondary and tertiary packaging material. So along with the product. So product is a primary contact of all these vials, septas, and silicone tubes. Before for example, if we take one example of injectable vials, before going to filling the product, we have a sterilization in place, that we'll wash with water, followed by drying, then again sanitation. Once the filling is completed, there will be a lyophilization in place. So all this comes under restricted air barrier processes. So there will be grade A, grade B, grade C, grade D. That's called as ISO 5, 6, 7, 8. Grade A is a most controlled point. The most of the operation, filling operation happens at grade A. So we have a restricted barrier. So there is an airflow pattern from, so the AHU controls which is into the place that has to be monitored periodically. The air changes per hour is a critical point here. So if we improve the air changes, then automatically the most of the controls will happen here. So movement of the personnel. So if you have a frequent movement of the person in the clean room, that shed a lot of particles. So we have to control those barriers. So it should be a limited area. The person has to be moved slowly. When we move fast, a lot of particles shed from our, including hair and other things. Even though we are closing our with the protected equipments, that has to be controlled. And we have to make a proper plan to have schedule, a manufacturing schedule. As one of the speaker mentioned that we have to focus more on this pandemic situation, which we have not estimated earlier. So we have to make a proper plan and periodical maintenance of the schedule. And one thing, while we are entering into a clean room, why do we remove all our watches, rings, and etc.? Because it's inanimate material, where there is a study says that 22 studies are performed. It lies 9 days lively. So we have to remove all our equipments there. So this is the study. The longest period is 5 to 9 days. Now, there are several criteria. For example, if a person is infected, what we do? We use 2% bacilloid. We do fumigation across the area. That is the highest concentration, 2%. Followed by equipment cleaning, followed by floor cleaning. Floor cleaning will have a 0.5% and equipment cleaning will have a 1%. Most of the equipment will be cleaned by 70% IPA, isopropyl alcohol. This is the strategy, and we have to have a document evidence to support these activities. And it's found that the enveloped virus will have a restriction to the cleanliness. But it's good to note that because of sterilization process in our autoclave, we make 121 degrees centigrade for a particular period of time, 30-35 minutes. But it is proved that the sterilization process is completely effective, and it will eradicate both enveloped protected as well as the other viruses. So what we do in this case, every 3 days we change our agents, sterilizing agents, because the virus may get some accumulated if we continue to use the same agent again. So what we do, we change that and we see the efficiency of these agents. So we discussed this ISO class 8 to class 5. Class 8 is the most stringent part, and we already discussed this personal protective equipment and sanitization. These are the important tasks. This is all focused by USFDA, both MHRA. So let us take one case study. For example, if a person is infected, here a person is displaying any symptom of isolated, immediately we have to isolate him. Then we have to see the videography and understand what are the areas he has assumed in. And we have to thoroughly fumigate for 3 consecutive days. That is the third action item we have to see, so that there are no contaminants, remnants left out. Then clean the area with 70% IPA. Then followed by floors, walls, ceilings with bacilloids and mini care. And we use equipment, glasswares, and all other consumables there. We have to identify them and clean them. We have to establish a systematic plan where there will be a checklist, so that we have a evidence that it has been cleaned thoroughly. As I mentioned, all primary can talks will be isolated and be conducted. Once there is a fitness certificate, then we allow them into the office. So here there are two ways. One is by operator infected by SARS-CoV-2, and second is incoming materials. So when the incoming material comes from other manufacturer, where there is a lot of handling in place. For example, it comes through a vehicle, and it comes through our warehouse systems. So where we have to identify with a checklist which are the parts is getting exposed. So there will be a decontamination procedure for the incoming raw materials before the sampling process takes place. After sampling, it will places into warehouse, then the batch release will be released. There is a tool called FMEA, that is failure mode effective analysis. We will see what is that FMEA. So now the formal risk assessment is in the FMEA having severity, occurrence and detection. We will see what is severity. Severity is a criticality of the failure, which is severe. Let us take, first I will take a simple example. Today I am walking through this floor. So there is a chance of falling the floor on me. Severity, occurrence and detection. So is it severe or not? For example, if it is lying there, I am walking for here. If it falls on me, there is a severity. Occurrence is what is the chance of occurring on me? How many times it may fall on me? So it depends on the incident of that. Detection, am I able to detect it or not? So if it is clearly visible, I am able to detect it, or I am not able to detect it. So based on that, all these three things have a rankings from 1 to 5. 1 is the lowest risk and 5 is the highest risk. This is the example. Now we'll go into the actual subject here. So 1 is a minor impact. So now we will come to the clean room evaluation. 1 having a minor impact, 2 is a moderate impact, 3 is a high impact, 4 is a highest impact. Now based on that, we have a criteria in place. So we will measure the risk there. So risk rating will be remote, low, moderate, high and extreme. Remote is failure is unlikely. It may fall on me, unlikely. Second is it may occur very few times. So like that we have to evaluate in all our scientific area. Based on that, based on the risk, we will propose a mitigation plan. How do we mitigate this? So based on that, based on my mitigation plan, again we have to perform a risk assessment, then the ranking will automatically comes down. For example, if we say risk is 5 into 5 into 5, the calculation is severity, occurrence and detection called risk priority number, RPN. That is 5 into 5 into 5 is 125 is the worst case. Based on my mitigation plan, it may reduce further. Let us take 5 into 3 into 2. Then 15 3s are 30. Now it is drastically reduced from 125 to 30. That is my quantitative measurements. Based on my preventive measurements, it has come down drastically. Like that, we have to make a quantitative assessment. This is called a risk-based assessment, FMEA, failure mode effective analysis. Once all items are scored, the RPN will be calculated by multiplying frequency, detectability and severity. That is called severity rating. That is severity rating into frequency into detectability rating. Suppose if the risk is high, is more than 40, that's called the highest risk. If between 21 to 40, it's a medium risk, and this is low, it is 1 to 20 is the lowest risk. Now decontamination. We use the HEPA filters. The air flows from AHU. Actually, it is not like our regular environment. We have to have a controlled environment. What we do, we have to have a air circulation passes through multiple. That is called air handling unit procedure. So air circulation continuously measurements that reduce shut out the particles. Each area will have a HEPA filters so that they have a perfect working environment. And there are several guidances, other guidances like ASHE and other flows are there. We can refer those guidances. In the conclusion, clean room environment plays a major role for all our manufacturing environments. And the people, equipment, facilities and measurements will be plays a major role. And recent information suggests that COVID virus does not grow on the conventional manufacturing areas because these preventions are taking care. And however, there is a frequency. For example, earlier in a shift, once in a shift we used to clean A, B, C. So thrice in a day. But now the frequency has been drastically increased once in 4 hours. During this process, whenever we are changing the disinfectant agents, there is a vendor qualification in place. So there is a vendor questionnaire, and we have to qualify based on the vendor questionnaire. In the current scenario, there is a possibility that there is a virtual audit is also in place. They were videography. We are monitoring their systems. We are evaluating their documentation part. We are assessing them thoroughly based on the satisfactory requirements. We are qualifying them as part of the placing them as part of the vendor list.